Over time, there will be thousands of different applications, sidechains, and nodes connected to the Cardano blockchain. This raises the need for a way to carry information across layers without having an entire history of the network. In this lesson, we will learn more about Mithril, a stake-based multi-signature scheme that leverages the existing Cardano network to provide certified snapshots of all or part of the blockchain's state. The first application of Mithril will allow faster bootstrapping of Cardano nodes. As each node has a full copy of the blockchain and needs to verify each block from the history, it takes a significant amount of time to start a new node from scratch. With Mithril, it is possible to start a node from a predefined state with the same security guarantees that the chain itself provides, but much faster. Mithril enables a multi-party signature by holding a number of individual lotteries and considering a message to be valid if it has been signed by a number of different winners over these lotteries. Each user therefore attempts to sign the message and then passes its signature through what is considered a lottery function. This function allows individual users to check if their signatures are eligible as lottery winners and output those without waiting. This is different from the typical scenario when minting blocks on Cardano, where slot leaders need to wait until their slot is active to participate. Once there are enough signatures over different lotteries, they can be aggregated into a single Mithril signature. Mithril works in a public setting where signers don't need to interact with other signers to produce a valid signature. The aggregator combines all the signatures into one, and this process is logarithmic with respect to the number of signatures. As a result, when applied to a full node client like Daedalus, Mithril can increase full node data synchronization, ensuring speed and decreasing resource consumption. To represent a significant fraction of the total stake, Mithril uses the stake-based threshold setting. This behavior is different from the typical proof-of-stake setting in which the given number of participants are required to validate a particular message. In the stake-based threshold setting, the protocol requires a fraction of the total stake to validate a given message to generate a correct signature. Mithril also certifies consensus in a trustless setting. This means that it does not include any additional trust assumptions. It is possible to achieve consensus certification without including any additional assumptions, other than those already present in the proof of stake. Finally, to ensure fast chain state bootstrapping, the signature scheme allows different stakeholders to validate only a given checkpoint of the chain. Stakeholders don't need to go through the whole transaction history of the given state, they simply need to go through the checkpoints to verify that the final stake is valid. This is beneficial for light client applications like light wallets that need to work fast without a full chain synchronization. This technology also has an interesting use case in relation to decentralized governance. Stake-based voting applications and governance solutions can use Mithril regardless of the voting protocol's complexity. Mithril signatures can be utilized for secure and lightweight tally verification. This is also useful when stakeholders go through a decentralized decision-making process and provide the final result in an easy and verifiable way. If you enjoyed this video, be sure to like and subscribe for more content like this. Another great way to help support the creation of this content is to delegate to Kaizen Stakepools. Join us for our next episode of the Cardano 101 course, where we'll learn about Midnight, a privacy blockchain that will be a future sidechain of Cardano. I'll see you there.